Greetings to Doctor and all viewers. I'm Lim Sushan from Group F. Now, my group will be presenting about the productions of Lajak Kuriuh Type F in December 2020. First of all, just like what we know, in the productions of health supplement diet tablets, the tablet uniformity, for example, their weight and also their hardness is very important and needs to be maintained within a certain range. So my group will be monitoring the quality of tablet productions for pure Lajak Kuriuh-F in December 2020. We will be using ANOVA tests, goodness of fit tests, as well as regression analysis to prove our hypothesis, like whether the tablets produced in December 2020 fulfill the requirements of the Food and Drug Administration Authority, FDA, and is there any relationship between the production shift and the quality of the product? Now I will be talking about part A, which is to describe and summarize the sample data. So there are 200 data collected from December 2020 as shown in this table. And by using the pivot table in Excel, we summarize the data into 3 different categories, which are the weight, the relative density, and also the tensile strength. In each category, we analyze the data in terms of their average, their standard deviation, and also their variance. And from the table, we can generate the chart. And from the chart, it clearly shown that the weight of most samples falls in the range of 350 to 360 milligram. As for relative density, most of them fall within 86 to 89. And lastly, for tensile strength, the mood will be 7.1. Besides, we also categorize the data according to their shift, like whether it's morning, evening, or night. It is to give an overview of the productions of tablets according to shift, for example, the average weight, the average relative density, and also the average tensile strength. And that's all for my part. My member will take over. Thank you.
For question B, we were asked to determine whether the Lajak Kuriuh-F tablets follows a normal distribution with mean 350 mg with standard deviation of 14 mg. So in this analysis, we performed the goodness of fit test at 5% significant level. So let me explain the 4 steps that we did to solve this question. So step 1 is hypothesis statement. We let X represents the weight of tablets. And our null hypothesis is X is normally distributed with mean 350 and variance 14, while the alternate hypothesis is X is not normally distributed with mean 350 and variance 14. So assuming our null hypothesis is correct, this is the transformation formula. And we move on to step 2, which is test statistics. So for this one, we proceeded to find the observed and expected frequencies, OI and EI respectively. And for this, we used the Excel pivot table and extracted the info from appendix for table F in e-learning. And since expected frequencies for I equal to 8 and 1 is less than 5, as seen here, we merge them with the adjacent ranges so that after that it's more than 5, which we merge row 1 and 2 as well as row 7 and 8. And then we found out that our chi-square test is equal to 2.5285 according to the formula given in the statistic textbook. And then for the decision rule, since we have 6 number of categories K and our unknown parameter P is 0, we can conclude that our degree of freedom V is 5 because 6 minus 1 minus 0 is 5. And then at alpha equal to 0.05, we found out with degree of freedom 5, we found out that the chi-square test is 11.0705 via the statistical table. So for conclusion, since the chi-square test for tablet F weight is lower than the chi-square test for alpha at 0.05 with 5 degree of freedom, we accept the null hypothesis and concluded that we have no evidence to reject the claim. Thank you.
So for the next part, we will be discussing about to see if there's any significant difference between the weight, the tablet weights and the different shifts. So first of all, what we have done is we have sorted out each weight of the shift or into each shift, morning, evening and night. Next, we used ANOVA single factor, which is available in Microsoft Excel, in one of these columns to get our values. So So first of all, we have established our hypothesis statement, which is given as H naught equals to mean 1 equals to mean 2, where there's no significant difference that will exist between the tablet weights from the different shifts. The next statement is H1, where significant difference does exist between the tablet weights from the different shifts. So next, our level of significance, we assume that alpha equals to 0.05. So next, our ANOVA single factor table is as given here. The first table is the summary of the values, where this is the count of the weights in each shift, and this is the sum of the weights in each shift, the average weight for each shift, and the variance weight for each shift. So next is the ANOVA table. As we can see, SS stands for sum of square, DF stands for degree of freedom, MS stands for mean squares. This is our F test, our P value, and our F critical. So we can see that our F critical value is much larger than our F test value. And if we notice, we can see that our P value, which is 0.890449, is bigger than our alpha value, which is 0.05. Hence, we conclude that we fail to reject H naught and that there is no significant difference existing between the tablet weights from the different shifts. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURIN TIHANI binti NAZEMI and I will be presenting question D. To investigate the prediction of the tablet's tensile strength based on the recent relative density values, we have decided to use the regression model analysis. This is because the tensile strength is depending on the relative density, which means that the tensile strength is the dependent variable, whereas the relative density is the independent variable. Based on the regression statistics, we obtained the sample correlation coefficient as much as 0.84. This value lies between 0.9 and unity, which means that there is a very strong positive linear relationship between tensile strength and relative density. And we can also see it here in the line fit plot, where the scatter diagram of the sample data are quite close to each other and they are quite close to a positive linear straight line. So that is in accordance with the sample correlation coefficient. And to further validify this regression model, the R-square value, which is the coefficient of determination, is 71.36%. Now, to predict the tensile strength value based on the data, we use the regression model line equation, which is displayed here. The y hat value is the prediction of the tensile strength, whereas the x variable is the relative density, and the beta naught hat value and the beta 1 hat value is determined by this model, which is here. This is the beta naught hat and this is the beta 1 hat value. By inputting all of this value, both of these values, into the regression model line equation, we obtained this equation. And if you look closely, this equation, the regression model line equation, which we have obtained from this equation, is the same as the line equation that is passing through the predicted tensile strength here. And by using that equation and using the recent relative density values, we obtain the predicted tensile strength as displayed in this table.